Dear students, so the procedure to be followed for performing stress analysis on trusses using ANSYS APDL page is going to be discussed in this lecture video. So already I have shared one more video in my YouTube page for truss analysis. So this is the second problem I have considered. So we know that truss element is nothing but the combination of one-dimensional bar elements, is it? So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, totally 13 one-dimensional bar elements are combined to form this entire truss element. So the truss element considered as subjected to loading condition at 3 nodal points and is supported by roller support and hinged support at its ends. Okay. So for simplicity, it is assumed that the material of the entire truss element is steel. So the Young's modulus of steel can be taken as 2 into 10 power 11 Newton per meter square. Okay, and it is assumed that the entire bar element is having uniform cross-sectional area of 1000 mm square. So to convert it into meter square, 1000 into 10 power minus 6 meter square, so 10 power minus 3 meter square. Okay, so how to solve this case using ANSYS APDL page, let us discuss. So first, it is a structural problem. So element type, we have already discussed that truss element is formed by combining the one-dimensional bar element. So the element type has to be selected as link, material properties, material models, structural, linear, elastic, isotropic. The Young's modulus value is 2 10 power 11. Then sections, link, add section ID 1. So 10 power minus 3 meter square, that is 001 meter square. Okay, then modeling. So we can model the truss element considered in the problem using nodes and elements. So nodes and active CS 1. So in this problem we can set the coordinate positions. So we can consider point A to be the reference. So coordinate position is 0, 0. The length data for each element is given below, 4 meter. So this is 4, 0, 8, 0, 12, 0 and 16, 0. The height is mentioned as 3 meter. So the coordinate position for point B is 4, 3. This is 8, 3 and this is 12, 3. Okay. Coordinate position 1, 0, 2, 4, 0, 0, 3, 8, 0, 4, 12, 0, 5, 16, 0. So the next point is nodal point 6, that is 4, 3. Then the 7th nodal point is having the coordinate position 8, 3, and the 8th nodal point has the coordinate position 12, 3. Okay, so we can join these nodal points to define the given truss element, auto numbered through nodes. So we can join 2 nodal points using elements Okay, so now we have modeled the truss element. So next we have to define the boundary conditions of the problem. So go to define loads, apply structural displacement, so on nodal points. Okay, so here in the problem it is given with roller support. So it can move about x-axis, so arrest uy and uz. Then at this nodal point hinged support is provided, so arrest all the displacement degrees of freedom. Okay, then loading conditions. So at this nodal point 80 kilonewton load is acting in the negative y-axis direction, so minus 80,000 force or moment on nodes. Select this point. Okay, Fy minus 80,000 Newton. Okay, next at this nodal point 120 kilonewton force is acted in the negative y-axis direction, so select this point. Okay, Fy minus 120,000 Newton. Okay, next at this point 200 kilonewton force is applied. Select this point. 200,000 Newton. Okay, so now we have completely modeled the given truss element problem. So now we can solve the problem using current load setup option. Solution is done. So to read the results, go to general post processor, element table, define table, add. We know that the sequence number for the axial stress induced in element is LS1. Okay, close. Go to plot results, contour plot, line element results, LS1. So this is the axial stress induced in the truss element plot. Okay, so the maximum axial stress induced 0.400 into 10 power 9 Newton per meter square, so that is 400 megapascal. Okay.